Hey guys, so in today's lecture, we are going to discuss gasification and types of gasifiers. So, as we have discussed, first, what is gasification? So, gasification, as the name suggests, that it gasifies the solid biomass. So, the definition suggests that gasification is a process of partial combustion in which solid biomass, usually in the form of pieces of wood or agriculture residue, is converted into combustible gas mixture. As it is said that it happens in partial combustion, so not on full combustion. So partial combustion occurs because the air supply is intentionally kept less than the amount required for the complete combustion of biomass. So, as a result, a gaseous mixture of carbon monoxide, carbon dioxide, hydrogen, nitrogen, and methane are called producer gas is obtained. So around 10 to 20% carbon monoxide is produced, 9 to 12% carbon dioxide is produced, 15 to 20% hydrogen is produced, 45 to 55% nitrogen, and 1 to 5% of methane is produced. In typical combustion process, generally oxygen is surplus, but while in gasification process, the fuel is surplus. Why? Because the combustion products require partial combustion. So, for partial combustion pass through the glowing layer of charcoal for reduction process to occur. During this stage, both carbon dioxide and water vapor oxidize the char to form CO, H2, and CH4. So, the following reactions as shown in the slide are C plus O2, that is CO2, C plus O2, CO, C plus H2O, CO plus H2, and CO plus H2, CO2 plus H2O, and C plus 2H2 is methane. So the moisture available in the mass is converted to a steam, and generally no extra moisture is required. So the partial combustion products this react with char. So now we are going to discuss various types of gasifiers. So first of all, what is a gasifier? So it is an equipment which gasifies a variety of biomass. It is essentially a chemical reactor where various complex physical and chemical processes takes place. Here biomass gets dried, uh, pyrolyzed, partially oxidized, and reduced. So here today we are going to discuss various types of gasifiers, that is downward draft, updraft, cross draft, and fluidized bed gasifier. So first of all, here as we can see in downward draft gasifier, the biomass or the fuel, biomass and air move in same direction. It is best suited, uh, the air and the biomass move in same direction. It is best suited for variety of biomass. An open top down draft type gasifier is shown as in slide. So biomass is loaded in the gasifier from the top, from the open top. In steady state operation, heat from the combustion zone near the air nozzle is transferred upward by radiation, conduction, and convection, causing wood chips. Causing wood chips, causing these wood chips to pyrolyze. This is our biomass to pyrolyze and lose 70 to 80% of their weight. This pyrolyzed gas burn with air. This pyrolyzed gas burn with air to form CO, CO2, H2, and H2O, thereby raising the temperature to 1000 to 1200 degrees Celsius. The product gases from combustion zone further undergo reduction with char and production generate production products like COH2O and CH4. The combustible products are known as producer gas. Generally, about 40 to 70% of air is drawn through the open top depending upon pressure drop conditions due to size of wood chips. Then combining the open top with the air nozzle towards the bottom of the reactor helps in stabilizing the combustion zone by consuming the uncovered char left and also by preventing the movement of the flame front to the top. The tar thus is eliminated in the best possible way by creating a high temperature oxidation zone. Then the gas produced is withdrawn from an exit at the bottom at, at the exit at the bottom and is reintroduced in the annular jacket for heat recovery. The hot gas which enters the annual jacket around 500 degrees Celsius around 500 degrees Celsius transfers some heat to the wood chips inside and improving the thermal efficiency of the system in addition to drying the wood in this zone. The raw hot producer gas flowing out is usually polluted with soot, tar, and vapor. The raw producer gas can be used as such for thermal applications. For purifying, it is passed through coolers. Tar is removed by condensation, whereas soot and ash removed by centrifugal separation. Mainly applications of this gasifiers are electric power generation either through dual fuel IC engine or 100% gas fired spark ignition engines. Next is updraft type gasifier. So here as we can see that uh, here also there is a biomass hopper. Then the working principle is same as the downward draft gasifier. It is also called counterflow type gasifier. In updraft gasifier, the air enters from the below the combustion zone and the gas is drawn off at the top. It achieves the highest efficiency as the hot gases pass through the fuel bed and leaves the gasifier at a low temperature. The gas produced has practically no ash but contains tar and the water vapor because of passing of gas through unburnt fuel. Hence, the updraft gasifiers are suitable for tar free feedstock like charcoal, especially in stationary engines. Then, next is cross draft gasifier. So an arrangement is shown in the diagram. Here air enters the cross draft gasifier through a water cooled nozzle mounted on one side of the firebox. The gas is produced in the horizontal zone in front uh, in in front of the nozzle and passes through the vertical grate into the hot gas pot on the opposite side. Because of the short path length for the gasification reactions, this gasifiers responds more rapidly for changes in gas production. The high exit temperature of the gas and low CO2 reduction results in poor quality of gas and low efficiency. Therefore, this type of gasifier is not in common use. So, then the next gasifier is fluidized bed type gasifier. So, this is the most versatile and biomass and any biomass, including sewage, sludge, pulping effluents, etc., can be gasified using this type of gasifier. So, it provides a means of burning any combustible material from wet sludge to refuse with high efficiency and with minimal pollution. The heart of fluidized bed combustor is hot bed of inert particles which are held in suspension fluidized by an upward current of air. Fluidized beds generally contain either inert material, sand, or reactive material, limestone, or catalyst. This aid heat transfer and provide catalytic or gas clearing action. The bed material is kept in fluid state by rising the column of the gas. Normally, the operating temperature of the bed is maintained within the range of 750 to 950 degrees Celsius so that the ash zones do not get heated to its initial deformation temperature and it prevents clinkering. When the gasifier is put in use, the bed material is heated to ignition temperature of the fed stocks. Biomass is then injected, causing rapid oxidization and gasification. Fuel gas so produced contains impurities, dust, char particles, and tar. It needs conditioning and cleaning for utilization as an engine fuel. So now we will see the common constructions which each and every gasifier is using, which we have not discussed. So as we can see that insulation is provided in each and every gasifier so that heat is not directed outside to the atmosphere. Then there is also an annular jacket which which helps the gas to flow through it, and each and every gasifier is having different zones like drying zone, pyrolysis zone, oxidation zone, and reduction zone. So in drying zone, the uh, the biomass is dried and the water content is converted to the steam. Then in pyrolysis zone, the biomass is converted into gas. Then in oxidation zone it is oxidized, while in reduction zone the it is converted into fuel with the help of addition of hydrogen. And then at the end ash and grate is produced, which can be thrown outside. So this is the common construction of a gasifier. Now we are going to discuss uh, scope of biogas energy in India. So what is the scope? Means how much energy we should produce or we can produce. So as has the largest cattle production in the world, the basic fed material for biogas plants in India has been considered to be cattle dung, which is available in plenty. And there are about 75 million farm families. 60% families own 4 or more cattle, while which are sufficient to operate a small biogas plant. Biogas pilot programs aims to install small scale biogas plants for meeting the cooking energy needs in rural areas of India. During 2011, some 45,000 small scale biogas plants were installed. Cumulative, uh, cumulatively, Cumulatively, India has installed 4.4 million small scale biogas plant. In 2011, the MNRE, Ministry of New and Renewable Energy Sources, Government of India started new initiative with the aim to demonstrate medium sized mixed fed biogas fertilizer pilot plants. This technology aims for generation, purification, enrichment, bottling, and pipe distribution of biogas. India has approved 21 of these projects with aggregate capacity of 37,616 cubic meter per day, of which two projects have been successfully commissioned by December 2011. India has additionally commissioned 158 projects under its biogas based distribution grid power generation program with a total installed capacity of about 2 megawatt. India is rich in biomass and has a potential of 16 gigawatt agro residue and plantation, 5 gigawatt bagages cogeneration, and 2.7 gigawatt energy recovery from waste. Biomass production in India is an industry that attracts investments of over 600 crores every year, generating more than 5,000 million units of electricity and yearly employment of more than 10 million man days in rural areas. India has been promoting biomass gasifiers technologies in its rural areas to utilize surplus biomass resources such as rice husk, crop stalks, small wood chips, other agricultural residue. The goal was to produce electricity for villages with power plants up to 2 megawatt capacities. During 2011, India installed 25 rice husk based gasifier systems for distributed power generation in 70 remote villages to Bihar. The largest biomass based power plant in India is at Sirhoi, Rajasthan, having capacity of 20 megawatt. During 2011, biomass gasifiers projects of 1.2 megawatt in Gujarat and zero point 0.5 megawatt in Tamil Nadu were successfully installed. India is endowed with a number of non-edible vegetable oil producing trees like Jatropha, Karanja, etc., which thrives in inhospitable conditions of heat, low water, rocky and sand soil, a renewable resource of economic significance. Ministry of Petroleum and Natural Gas has opened a biofuel center in Delhi to build awareness of importance of Jatropha curcuis cultivation and manufacture of biodiesel.